Alrighty, let's take some notes on 7.3. So our first two sections of this chapter have been on law of sines. First it was just straight up law of sines and then the ambiguous case. Today we learned law of cosines. Okay, so on a test I'm going to tell you right now, you're going to have to determine when the law of sines and law of cosines are appropriate for solving a triangle. You can either draw pictures and reason your way through them, or else if you memorize this right here, law of sines are these three scenarios, law of cosines, we got to use those two. Okay, and after we actually do a couple law of cosines problems, I think that'll make a little more sense. Okay, so 7.3, law of cosines. Also, like law of sines, works for any triangle, doesn't have to be right. And this is the formula. Okay, so c squared is equal to a squared plus b squared minus 2ab cosine c. Now, a, b, and c, do not get hung up on that. This is the key thing here, that side c and the angle c there must be the side and its opposite angle. Okay, so I could plug an a in, angle a right there, and side a in right here. It's just got to be a side and its opposite angle. Okay, because otherwise there would be infinitely many of these formulas that you have to memorize, because if I give you RST, you'd have to remember like r squared is equal to s squared plus t squared minus 2st cosine r. We're not going to do that, okay? So these are the three forms the book gives you. Just memorize one of them, and I cannot stress it enough. Just know that's a side and its opposite angle, okay? So we're going to start this off. Solve triangle, we'll do ABC, where I know A is 60 degrees, B is 20, that's side B, and side C is 30. Okay, so the three things that I got to find here are angle B, angle C, and I've got to find what side A. Okay, so could we use law of sines here? And the answer is no, because I would have to go like sine of 60 over x is equal to, I don't know the angle opposite, or yeah, the angle opposite 20 or the angle opposite 30. So this is where we've got to use law of cosines, and this is on that first page where we said if you have side angle side, you need to use law of cosines. Okay, so my goal is going to be, because this is the angle I'm given, I've got to use this opposite side. So just going back to our formula one more time, it's the side squared, so I'm going to say a squared is equal to, now you take, it's like Pythagorean theorem, you square the other two sides, so a squared is equal to, this is going to be 20 squared plus 30 squared, minus 2 times, it's AB, so AB, which is 20, 30, just my other sides, 2 times 20 times 30, times the cosine, and now notice that it's whatever side I used, it's the opposite angle, so cosine of 60, that was my point of reference. Okay, so you definitely need to be able to type this into a calculator. A ton of kids screw this up. This is going to be a squared, and I would do this in steps here, okay? I would type this into your calculator, hit enter, and then go minus 2 times 20 times 30 times cosine 60. All of this comes out to be, I believe, 700, because cosine of 60 is just a half. So it does come out nice for us there. When you square root, then we get that A is equal to about 26.5. So my side A is like 26.5, and technically I suppose we should say units. Okay, so there, I'm going to color this in. Now I'm going to do my 26.5. Now, could we use law of sines at this point? Well, could I go sine of 60 over 26.5? You could, but remember that value's been rounded, so I would probably discourage you from doing that. I guess we're going to have to do that with law of cosines as well. And I'm going to talk about this in a couple of slides where you have to be careful if you start with law of cosines. But just because we haven't practiced law of cosines, we're going to use law of cosines to find these angles, okay? So I'm going to go and let's find B first, since that's the one we labeled. So I'm going to erase this here. Didn't want to erase the whole thing. So this is the angle I want to find. So that angle is going to be my unknown right there. Okay, the side opposite is 20. So I'm going to say that, and I should probably do this in a different color. 20 squared is equal to 30 squared plus 26.5 squared. Now remember, this is a rounded value. If you have that value in your calculator, a graphing calculator, use that, or else write out the whole entire thing. So that's 26.5 squared minus 2ab, so minus 2 times 30 times 26.5 times the cosine of that opposite angle. What I'm trying to find is b. Notice, guys, that these two are always going to be the same. The AB, it's just the two other sides that you're not using for the opposites. Okay, so this one is even more difficult to do in multiple steps, or more difficult to do in one step, so definitely do it in multiple. Here's what I would do. Take 20 squared, hit enter. Subtract these two values added together. Okay, so you're going to go 400 minus whatever you get out of that. So that is going to give me negative 1202.25 is equal to, I've still got negative 2 times 30 times 26.5 times, and I don't need the parenthesis there, times the cosine of b. Okay, I would multiply all of these together and then divide negative 1202.25 by that. That's going to give you roughly, I don't know if it comes out exactly as this. It's about 0.7561 is equal to cosine, not 661. 61 is what I have written down here. Is equal to cosine of b. In order to get b by itself, I've got to take the inverse cosine of that value. When you do that, we should get that b is a roughly 40.9 degrees. Okay. C is then, I can just take 180 since this was 60 and I knew B was 40.9. And take 180 minus those two and we would get that C is 79.1 degrees. Okay, so that was just using law of cosines twice. There are going to be times where you can use both. Sometimes you have to use law of sines. Sometimes you have to use law of cosines. Okay, so on this second one, we will now use law of sines after, just because typically that's quicker. This is what we'll talk about here. You have to be very careful when doing law of cosines first and then following it up with law of sines. Okay, triangle, what do we got? ABC. What do we have here? So A is 34, B is 20, and C is 18. Okay, so this is side, side, side. I could not start this with law of sines. I would have to definitely do law of cosines. So I've got to find angle A, angle B, and angle C. It doesn't really matter which one you do. Which one did I do first last time? I found C. And again, not that it really matters there. Okay, so angle C, if that's what I want to find, remember our formula is the side opposite. So I'm going to go 18 squared is equal to the other two sides squared, 20 squared plus 34 squared, minus 2 times 20 times 34 times the cosine of C. That's what I'm trying to find. Okay, so again, take 18 and square it. Subtract these two values squared. When you do that step, you should end up at negative 1232 is equal to negative 2 times 20 times 34 cosine C. Okay, now multiply all of these numbers together and then divide that out. You should come up with like 0.9059 is equal to the cosine of C. Take the inverse cosine. We should get angle C is equal to 25.1 degrees. So angle C we'll say is 25.1 degrees, which again is a rounded value, so be careful moving forward. If you have that stored in your calculator, use it. It'd be way easier if we were doing this in person so I could show you guys how to store it. But like I said, I'm sure I've said this a lot. I'm not going to be super picky about rounding. Okay, so now we can use law of sines if we want. I am going to go and find, doesn't really matter on this one. Let's do B. So I would say if I want to find B, switch up the color here. If I wanted to find B, I would say sine of B over 20 is equal to sine of 25.1. over 18. So this is going to give me the sine of b. Again, this is just cross multiplying, so it would be 20 sine 25.1 over 18. Take the inverse sine of that, and you would come up with angle B should be equal to 28.1 degrees. Yep. So then angle A we get is 126.8 degrees by taking 180 minus A minus C. Okay, guess what? They're back. Heading and bearing problems, and here's the horrible news is that we can't just assume they're right triangles anymore, because they're not going to be right triangles. Okay, so just a quick reminder, headings come from true north and rotate this way, clockwise, and bearings would be like north 30 degrees east. Remember, is like east 30 degrees of north. Okay, so drawing your picture is the biggest thing here. If you remember when we did these in class, I had to do them on the board, so hopefully I can draw them better now that I'm sitting on my couch doing this. Okay, a plane is flying with an airspeed of 185 miles an hour with a heading of 120. Okay, so I'm going to start up here. This is my start point. And I've got a heading of 120 degrees. So if you guys remember, trying to draw these as accurate as possible always makes life a little bit easier. Okay, so there's that. I'm going to call that 185, and that angle was 120 degrees. Okay, the wind currents are running at a constant 32 miles per hour at 165 degrees, which I again assume is a heading because they didn't say anything about a bearing. Okay, so I'm going to zoom in here. I'm going to make my new XY axis. And this one is 32, and it was at 165. So I'm going to use a different color here. 165 would put you about there. I should have made this a little more. Let me back up just to, because you guys are going to have a tough time following that picture if I draw it like that. Okay, let's try this again. So my 120, I'm going to leave a little bit short of 120. That's a little better. Okay, so now we're at 165. Will probably work out a little bit better. Okay, so if you remember what we talked about, like that was my starting point. This is where we end up down at this point. I want to know the true course and the ground speed of the plane. So ground speed, if you remember, is just the vector in green that I drew that resulted. Okay. So it's pretty obvious this is not a right triangle. So in order to find the ground speed, in the previous ones, all we ever had to do was Pythagorean theorem because it was a right triangle. Now we're going to just have to do law of cosines. Okay, so I'm going to call this C. The problem is, in order to do that, I need to know what this angle right here is in my triangle. Okay, and that's where it gets a little tricky now, because we've got to be thinking a little bit about geometry here. Okay, so when I rotated, okay, so follow me here, this part's going to be in, I'll switch the color up, orange down here. When I did this, this was 165 degrees. And I'm going to kind of blow that part of the graph up where I have this. So I've got this coming off here and this coming down here. This was my 165, which means that this little piece right here is 15 degrees. Okay, this one is 90. Now it's just a matter of, can I figure out what that piece right there is? Because if I do find that out, I could just take 90 plus 15 plus whatever that value is. Now, can I zoom in any further? No. Okay, so this piece right here and this piece right here have to be congruent because they're alternate interior angles. Okay, so if the whole thing was 120 degrees that I rotated, and then I want to find just this little piece in black that I drew there, I would want to take 120 and subtract off that extra 90, which tells me that that little piece in there is 30 degrees. Okay, so if you take and you add up 30 plus 90 plus 15, that's going to tell me that this angle, and I need to erase a couple things here so I'm not confusing you. This angle on the inside right here is 135 degrees. So now that I know that, I have enough to go and find the ground speed using law of cosines. Okay, so I'm going to say my side, c squared, is equal to my other two sides squared, 185 squared, plus 32 squared, minus 2 times 185 times 32 times the cosine of the angle opposite it. That's why we had to find that 135, so it's cosine 135. Okay, so this one's kind of nice because all you got to do is just basically type everything into your calculator. There's not a whole lot to do. One thing I do want to mention, because I don't think I did before, guys, is you should get to the point where this is like c squared is equal to 4,300 or 43,621.14429. Do not forget to square root that. It's very easy to make that mistake. Okay, so we should come up with here that c is equal to about 208.9 miles per hour. Now it's just a matter of 208.9 miles an hour in what direction. Okay, so what we always talked about was if you start here and they end here, they crash land, and it is your job to tell the rescue helicopter the quickest way to get there. You wouldn't send them on this route and say, okay, now you're going to turn and you're going to go this way. You'd want to go along that green route right there, okay, our resultant vector. So on this one, here's the whole idea. If I wanted to send them on the path of that green line, I'm going to zoom back in again here, and I'm going to do this in black. From here to here would be 120, but that only takes them along that route with the 185 here. I've got to go a little bit extra, so what I'm going to do is I'm going to call that little angle in there theta, and my true course will just be 120 degrees plus whatever that angle theta is. Okay, so now it's just a matter of finding that angle theta. Now you got to be careful here. Because when we look at this picture, I obviously didn't do a great job of drawing this one. But when I look at that, I've got to think, can I use law of sines or law of cosines? Well, I do know that angle theta, I know its opposite side is 32. And I also know the 135 and its opposite side. So we could just do sine of theta is equal, or sine of theta over, 32, because that is the side opposite that angle. That is equal to sine of 135 over that 208.9. So this is going to give me the sine of theta, if we cross multiply, would be equal to 32 sine 135. Sine 135 over 208.9. From there, take the inverse sine, and we should get theta is equal to 6.21 degrees. So that is that tiny little piece in there. So if you were trying to send a rescue helicopter out to these guys, you would say or tell them to go on a heading of 126.2 degrees. So ground speed was what we found originally, 208.9 miles per hour. With a heading of 126.2 degrees. I don't know what, does it say it around any special way? No, it doesn't. Okay, that 126.2 just came from this plus our original 120. Now, let's talk about this, because this is really important, okay? Because inverse sine always returns an acute angle, you have to be careful using it after you've already used law of cosines, okay? So when you think back to your inverse trig functions, sine was in between 90 and negative 90, so it was always going to return an acute angle. If you think back to the cosine restrictions, that was between 0 and 180, so cosine will give you either the acute or obtuse angle. It works itself out. Okay, so there's two things that you can do to see that you don't make a mistake, and I'm going to show you the mistake that happens after we talk about this. First one is that always find the smaller of the two remaining angles when using the law of sines after the law of cosines. The second way is if you start by using law of cosines, only use that to finish your problem. And you totally can do that. Most of you aren't going to like law of cosines as much. So my hunch is that most of you will go this route. Okay, so again, once you have already used law of cosines, if that's step one and you now want to use law of sines, you have to go and find the smaller of the two angles, because any triangle, the smallest angle is guaranteed to be acute. Okay, if you find the biggest angle isn't necessarily obtuse. It could be obtuse or acute, because if you think about an equilateral triangle, I mean, those are three acute angles. You can't have more than one obtuse angle, though. Okay, so let's see if we can kind of make some sense out of this. So what I am doing right now is showing you the wrong way of going about this. Okay, and we're going to see if you guys can pick out the contradiction that we have here. So I'm going to do triangle ABC. A is 23.4, B is 38.6, and C is 35.1. So in order to solve this triangle, the first thing I would have to do is come over here and find side C using law of cosine. So I'm going to skip some work, but I will set it up. So I'm going to do that up here. C squared is equal to be 38.6 squared plus 23.4 squared minus 2 times 38.6 times 23.4 cosine of 35.1. If you go through and you type all of that into your calculator, that gives you a value of 23.7. Okay, so I'm going to say here's my next step. I've got this being 38.6, 23.4. This is 35.1. This was, what did we just say? 23.7 is what you get when you solve that. Okay, and this is A, B, C. So this is our scenario. We just use law of cosines. Part 1 says always find the smaller of your two remaining angles. I'm going to do this wrong, and I'm going to find the bigger angle first. Okay, if I look at my two remaining angles, the bigger angle is B because it's opposite the bigger side. So again, this is wrong. You would want to find angle A if you use law of sines now. Okay, I'm going to use law of sines, and I'm going to find angle B, and we're going to talk about why that messes everything up. So I'm going to go sine of 35.1 over 23.7 is equal to sine of B over 38.6. If we go through that process, erase that, you would get here that angle B is equal to 69.5 degrees. Okay, so 69.5, and then you can take 180 minus that, and we would do 75.4. Now, here's our issue. The largest angle has to have the largest side of the triangle opposite. It does not. The largest side of the triangle right now is 38.6, and that's not opposite the largest angle. So that's where our contradiction comes in here. Now, here is the big idea. If you, or I shouldn't say if, well, maybe I will. If you did it this way, you need to be careful, because you don't know that angle. When you type in the inverse sine of whatever that came out to be, sine is going to give you a value, but sine is positive in these two quadrants. And I don't know, is it that acute angle or is it that obtuse one? Okay, if you go through and you were to find this angle first, because what did we get? 69.5? Yeah, we got 69.5 here or there. If I work backwards, 110.5 is what you get, and that is actually the correct answer on this one, because you've got to find this one first down here, the smaller side, and then do 180 minus all of that. And if you guys want to try that on your own, you will see that you do get 110.5, which is an angle with a reference angle of 69.5 degrees in quadrant 2. Okay, this section, after we talk about this and combine it with the other two, typically even when I'm teaching it and kids are able to come in for help, does not go very well. So please make use of office hours. Let me know what I can do to help you guys, if anything. Your homework assignment is 351 to 352, 1 through 27.